Okay, so a little overview of the final project. Everything is already posted on Google Classroom. I've got the link to this PDF. I've got links to some resources, links to some video tutorials that I filmed for y'all. So you can scroll through this at your leisure, but I'll just do a kind of a quick run through of like pretending that I'm doing the project for you. So you are graphing a picture in Desmos. So these are your criteria right here. I'm gonna be really strict on having at least 15 lines. A good project would have like, I would say at least 50 to be honest, but 15 is what I'm gonna require. These requirements I'll be a little bit less strict on, just so you guys know. So the main idea is that we're gonna be graphing a picture in Desmos, which is basically like, I'm gonna pop on over to Desmos here and sign out so I can show you how to sign up. It's as though you're finding a picture and then you're graphing the lines to trace the outline of it. So when you start, the first thing you're gonna wanna do is go to desmos.com/calculator. So it should be the regular Desmos with the black banner, not the green one. And then you're gonna sign up so that you can save your work. So sign up, agree, and then sign up with Google, and it's just that easy. So I chose Tigger for my example project. So I'm gonna go over here to add item, click image, and then let's see, let me go to my Tigger picture. Where is Tigger? 1 second. Here he is, okay. So I'm gonna make the opacity around 0.5 so I can still see through it a little bit. Maybe I'll make it a little bit more, 0.7, let's say. Okay, so your goal would be to graph the outline of your picture using lines. So, of course, we have our best friend linear functions and our other best friend quadratic functions. I'll go over a couple of other functions, well, not functions, but graphing types in this video so that you can have access to the same info that your classmates do. But I'm gonna start with just like maybe trying to graph this part of Tigger's arm. So I'm gonna break down this into lines or shapes, and I can see that this part would be like a straight line. So we know that that's equal, or the equation for that line would be y equals mx plus b. And I'm gonna show you what I can do in Desmos that's really cool. So I'm gonna tell Desmos that y equals mx plus b. So I'm not plugging anything in yet. And it's gonna ask me if I wanna add a slider for m and b. And I'm gonna say yes, I want both of them. Okay, so, ooh, that actually lined up really nicely right away. But now you've got a slider to play around with so that you can adjust it as needed. And I can see that this slider is kind of finicky. I'm gonna click on the endpoint and now I can adjust it. I'm still gonna go between -10 and 10, but when I drag the slider, I want it to be really, really sensitive. So I'm gonna make it go up by 0.1 each time. So now when I drag my slider, I have a little bit more control. Actually, no, I'm gonna make it go 0.01. So now I've got a little bit more control than I did before. And same with my y-intercept, I can shift that around as well until I'm happy with my line. So as you may notice, this line goes on forever, but I only want it to go from like right here to right here. So I'm gonna restrict my domain in Desmos, and here's how you do that. So I want it to go from the x value of about 0.83 to about 1.5. So I'm gonna go to the end of my equation right here. I'm gonna do curly bracket, which is right under your backspace key. And we'll do 0.83 is less than or equal to x, which is less than or equal to 1.5. And now Desmos has restricted the domain of that line to just between those x values. So the idea is that you're going to be doing that for the entirety of whatever design you choose. So I'm going to show you how to do that again. I'm going to use another straight line. I'll maybe do this right here. I know it's a little bit curved. I'm going to pretend that it's straight. So I want you to notice, I'm going to type in y equals mx plus b again. And it didn't ask me if I wanted sliders again, because I already have a slider for m and b. And Desmos doesn't know that I'm talking about a new m and a new b. So I'm gonna go here and I'm just gonna type 1. It automatically makes it on the bottom, and B1. And now Desmos knows that these are separate from the line up here. I'm gonna have all new sliders for my purple line. So again, I'm gonna make my sliders be a little bit more sensitive. I'll go between -10 and 10. I'll step by 0.01, and same right here. -10 to 10, and stepping by 0.01. So I want that purple line to be right over here. So it looks like the slope is pretty nice. I just need to move it down. So I'm just gonna play around with my y-intercept. Something like that. I probably should use a parabola because it is pretty curved, but you guys get the idea. So again, I'm gonna restrict my domain from 1.27 to about, I'll stop it right here, 1.9. So curly brackets, 1.27 is less than or equal to x is less than or equal to 1.9. And always make sure that your domain or range goes from least to greatest. So, other things, well, what if I did want to graph a parabola? Like I'm seeing right here that Tigger's kind of chin is like a curved shape, like a parabola. Well, instead of saying y equals mx plus b, I'm going to put in vertex form. So y equals a times x minus h squared plus k, and it gives me options for sliders. I'm going to say yes. So that's the initial parabola that it gives me. Let's play around with that. I want it to be a little bit skinnier, and I want to move it over maybe right here, and maybe move it down a little bit. And maybe I want it a little bit wider, move it down a little bit more, and I want it to cut off right here, and maybe right here. So I'm going from -0.373 to +0.835. So again, I'm going to say -0.373 is less than or equal to x is less than or equal to 0.875, was it? I can't quite remember. I think so. And again, it does the same thing. It cuts off my parabola right there. Okay, lastly, a little bit of algebra 2 for you guys. This is optional. You don't have to use this if you don't want to. But say that I wanted to graph Tigger's nose. So I could say that that's like 2 parabolas, one concave down and one concave up. But the thing about parabolas is they don't curve back in. So those parabolas are actually going to meet in a point at the sides right here. It's going to be like a little triangle type shape on the sides. So next year, you're actually going to learn how to graph a circle or an ellipse, which is kind of a math word for an oval. And the formula for a circle, I'll just pretend that this is circular, is x minus h squared plus y minus k squared equals the radius squared. So I'll try a radius of 1. That's way too big. I'll make it smaller. Let's say 0.2. That's about, even 0.1. Let's try that. So you'll notice that it did not give me an option for a slider for h and k. That's because I already used h and k right here. So I'm going to call that h1 and k1. And now I have sliders. And actually, I'll even call that, it's really equal to r squared, where r is the radius. So I'll have a slider for r as well. Okay, adding my sliders. Let's make this thing a lot smaller. I want some more control. Again, I'm going to make the steps smaller, so -10. Actually, I can't have a negative radius. 0 to 10. I'm going to step by 0.01. And now let's try. Okay, maybe something like that size, and I'm going to move it up until it's where I want it to be, and I'm going to move it over until it's where I want it to be. Maybe up a little bit more. And again, if you want that to be if you want to be able to control it really, really well, you can always go in and adjust your step like I've been doing this whole time, 0.01. So now when I use this slider, it's going to be a lot more controllable. Okay, what if I wanted to be even more specific and give Tigger an ellipse for a nose instead of just a circle? here is the formula for that. I'm going to have x minus h2 squared over a squared, and I've already used a, so I'm going to have to call that a1 plus y minus k2 squared over b1 squared. I already used b1, I'm going to have to call that b2. There we go. Equals 1. I'm going to add my sliders. So this is an ellipse. You can actually, a circle is an ellipse just with a radius of 1, but if I make this different, then you can see that, like, if I adjust A but I don't adjust B, then I'm going to get really big side to side. So I'm going to make that a little bit smaller that way as well, making it smaller and smaller until it fits what I want. I'm going to go ahead, I'm going to hide my red one just by clicking on that red circle right here. Oops, if it'll let me. Go away. Here we go. Okay, and then I'm going to move it over. I'm going to move it up. And then I'm going to make it smaller. And smaller and smaller until I adjust it just how I want it. But y'all kind of get the idea. Those are the two main conic shapes that I want you to, that I think are most likely to be included in your designs. So far I've had people doing logos, cartoon characters, just like whatever you can come up with in your imagination. But again, they don't have to be this detailed as Tigger. I've had people literally just do like a drawing of a house and a stick figure. I've had people do things as detailed as a minion or a Pokemon. So it's totally up to you. And again, I'm sending these to the students who are absent, and I know that you are absent, so you have less time. So if you're having trouble doing something detailed or meeting all the requirements, I will work with you. It's not your fault that you were absent. So let me know if you have any questions or if this made sense, didn't make sense, blah, blah, blah. So anyways, that's it.